Hello students, and welcome to my video on inverses of functions. So I would like you to think about the word inverse, which means backwards, reverse, opposite. For instance, so we're going to be finding out the inverse of a function. So to find the inverse of a function, just swap the x and the y. That's what inverse of a function means. It's just, what do you do when you swap the x and y values of the function? You get the inverse. So we're going to try some examples of different kinds, tables, graphs, and then on the back algebraically. So here's a table. I've got some kind of function here. In fact, I'm going to go ahead and plot the points. So I got my function here, and I'm going to go ahead and connect the dots. I know this is half of a parabola, so I'm going to go ahead and connect it so I can kind of see this shape a little bit better. There's my half parabola. So I'm going to label that f of x. Remember, f of x just means it's the name of the rule. That's it. So the name of this rule is f. Okay, so I want to find the inverse of this function. So what that means is I'm going to take my old outputs, my y's. My y's become my x's. So I'm just going to copy my y values onto the x column. Okay, then I'm going to take my old x's and copy them to the y column. That's it, and there's the inverse of the function. So this symbol right here, before we get to the graph, let me just do an aside. This symbol, that right there, means inverse. But that just means inverse. So if you see f inverse of x or f to the negative 1 of x, that's just what that means. Let's go ahead and plot the inverse. So there's my inverse. Here's my function f and the inverse of function f. That's all there is to it. So if you've got ordered pairs or a graph, that's all you've got to do to find the inverse of the function. Now I do want to show you one thing. Turn your paper kind of diagonally like mine. And notice that this line, the line y equals x, by the way, the one that just goes straight diagonally through. Notice that that's a mirror. So inverses reflect over the line y equals x. So let's write that here. Inverses So if you turn your paper diagonally like this, and just imagine that this is a mirror, and the two functions are looking at each other through the mirror, the function looking at its reflection through the mirror, there we go, then you know that they're inverses. So let's look at these. So the domain of the function becomes the blank of its inverse. So remember, domain are x values. So if I took the x values of the function and they became the y values of the inverse, then the domain of the function becomes the range of its inverse. So the x's become y's. And then same thing here, the range of the function, so the y's of the function become the x's, or the domain of its inverse, and then possibly with restrictions. And we'll talk about this part when we get to the functions that actually applies to. Don't worry too much about that right now. So let's do a few of these together. So state whether each pair of functions are inverses. So let's look at this first pair. And since it's a graph, let's do this test. Let's turn our paper diagonally and kind of sketch in that line. Do the functions reflect each other? Does it kind of look like a mirror if I had drawn the line straight anyway? And they do. You can kind of see they kind of meet here. They're like a person looking at their own reflection or something in the mirror. So yes, these two are inverses. So I'm going to have you try first this one. So turn it diagonally. And ask yourself, does one reflect the other over this line? Okay, good job. No, they don't. So they reflect each other over the x-axis. So they definitely do not reflect each other over this line. Okay, so now look at the third one. And no, these are also not inverses. They do not reflect each other over this line. They actually reflect over the x-axis as well, but not the line y equals x. So they are not inverses. Okay, this is a big confusion for kids every year. This is a no. If they're just upside down on each other, they are not inverses. So then let's look at some table examples. So remember the x and y switch. So look at these x's and ask yourself, did the x's become the y's of the inverse? Well, no, they're completely different. Those are not the same number at all. In fact, all that was done here was somebody took the points of the function f and put negatives in front, except that one that became positive. So they just switched the signs of them. That is not inverse. That's another big confusion every year with kids. You switch the x and the y values. Do not change the signs. Okay, so go ahead and try this one. Do the old x's become the new y's? And do the old y's become the new x's? They are, in fact, inverses. So the x's become y's and the y's become x's. And finally, the third example. And the answer here is no, they are not inverses. In fact, all that was done was somebody took the list of numbers and just listed them in a different order. That's not an inverse. On the back, we're going to look at what if you have the equation and you don't have a graph of the line, you don't have points, you have the equation itself and you're asked to find the equation of the inverse. I'm going to show you how to do that. So the first thing I want to do is simplify each side of the equation if there's something to simplify. So if I wanted to here, I could go ahead and distribute this 3, which actually I think I'm going to go ahead and do. So f of x equals 3x plus 1, plus 3. So 3x plus 3, don't do what I did, minus 4, which equals 3x minus 1. Okay, so I simplified it a little bit, that's all I did. So now, step 1, swap x and y in the equation. Remember I said all inverse means is just swap the x and y, so that's all I'm going to do, swap the x and y. So this is, remember this is y, so I'm going to swap the x and y. And I'm kind of writing on step 2 here, but that's okay. So x equals 3, y minus 1. Now technically that's the inverse, and I could be done, but I'm mean and I'm not gonna let you be done. I want you to get y by itself now, so that it looks, so we can put it like in this form. Okay, so step 1 is done though. I switched x and y, done, yay. Step 2, now use Pemdas in reverse to solve for y, get y by itself. So to solve this equation, reverse Pemdas. Now you've done reverse Pemdas before, you may not have called it that, but you have done it. Every time you solve an equation, that's what you're doing. So I want to start by adding or subtracting anything outside the parentheses. Now I got rid of the parentheses already, I simplified them, so do I have anything I can add or subtract to get this y alone? Well, yeah, I need to get rid of this minus 1 there, and I get rid of minus 1 by adding 1. A negative 1 plus 1 cancels out. Now this right here is a point of struggle for some students. X plus 1 is simply x plus 1. You don't know what x is, so you can't simplify that. Like some kids will try to do, oh, now that means 2x or it means 1x or something like that. Don't do that. It's just x plus 1 equals 3y. Then multiply or divide by any number outside the parentheses. Again, I already got rid of my parentheses, so I don't have to worry about that part of it. But is there anything I can add or rather multiply or divide? I do need to divide this 3 away, so I don't want that 3 there, I want the y by itself. So if I have 3 times y, I get rid of that by dividing by 3. Okay, so here's what I have so far. Step 4, now you are at the exponent step. So remember I did add, subtract. In fact, I'm probably going to have you guys write it out. So I did add, subtract. I did multiply, divide. I'm at my exponent step in PEMDAS. Now this problem has no exponent, so you can skip that step, you're done with it. And then finally we're inside the parentheses. If I still had parentheses at this point, I would then take care of anything inside them, but I already got rid of my parentheses, so I don't have to do anything there. So, good. And then finally step 6, write using f inverse of x, and you're finished. So write using f of x notation. So let me rewrite my problem. So that's what I had. So instead of writing y, I'm just going to name the function. It was function f. Now it's the inverse of function f. And that's it. So I found the inverse of the function. Let's try number 2. Let's try one more. So find the inverse of h of x equals 3 times x plus 5 plus x. So this is a little different because we got this other x hanging out here. Definitely want to simplify first. So let's do that. So I'm going to distribute the 3, and then I'm going to combine like terms and add that x to the other x's. So go ahead and call that y. Y equals 3x plus 3 times 5 is 15 plus x. Now 3x and x are like terms. 3x's plus 1 more x make 4x's. And then plus 15. Okay, so here's my equation, h. Now I want to find its inverse. So step 1, swap x and y in the equation